Hello and welcome to my channel. As you can see, today we're going to check the robot from the Direct Drive Tech company. And from this name you can guess that this robot is going to use the direct drive technology. Direct drive means that you connect your output load directly to the motor without any gearbox. And there are some advantages and disadvantages of this technology. Advantages: this technology is quite simple and quite cheap. And the second main point is super fast and agile. The disadvantages: you either use small motor and your actuator is weak, or you use big powerful motor. In this case your actuator could be quite powerful, but at the same time it becomes heavy and bulky. But if we look at the biological systems, like for example human, we kind of use direct drive, I think, if I'm not mistaken. Because our muscles, they are connected directly to the bones without any gearing system. Probably this indicates that this is the future, and probably in the future we will develop a new motor which is going to be more lightweight and more powerful than our traditional motors now. And in this case we don't need to spend our money for the expensive gearboxes. We're going to spend our money for expensive motors. Yeah. Okay, anyway, let's look at this robot. I think it's going to be really interesting, and I think we're going to learn a lot from it. Ta-da! This is the robot itself. These are the motors for the direct drive. I think these motors are responsible for going up and down. Inside the wheels there are two other motors for the driving. And there are one motor over here and one motor over there. I think these two motors are responsible to move the legs like this. Over here and here I have some direct drive actuators. Like this we can test them. And there is a box with the tools, joystick, manual, screws and nuts, and charger. Let's quickly open this direct drive actuator. Some nuts with the connectors. I like connectors. So we have the power connector, and we have another connector which I don't know what, but probably it's a CAN bus. And this is the actuator itself. It's a really small one. And it's quite impressive that they managed to put the controller inside. The second actuator is quite similar, but it's a little bit bigger. And I suppose it's made in order to be built in the wheel. Because you can see this part looks like a shaft. The same connectors over here. And now let's look at the robot. I think this is the most interesting for you and for me. The weight of this box is 31 kilo. So the box itself is quite heavy, but the robot also quite heavy. I think the robot should be around 20 kilos. I suppose this is a back, emergency stop button. There is also this button, probably this is a power button or something like this. I think this is the charging port. I don't have the battery. I need to install it. As you probably already figured out, this robot can sit, stand and even jump. There are two small wheels here in the front and two other at the back. When the robot is not powered or when it's in the sitting position, it stands on these wheels. It looks actually quite cool with all these carbon fiber parts. I should say that this is pre-production module, and there are some 3D printed parts, like for example this one. Probably they're gonna change this in the production module. Joystick, forward, backward, left, right, pitch, roll. This is disable, low speed, high speed, jump. This is sitting, standing, and this is to adjust the height in the standing position. This plate here in the front is mounted with the thumb screws, and so it can be easily unmounted without any screwdriver. The same for this plate at the back. Let's check what is behind them. I have unmounted this plate. Here we have the power distribution board. The power goes here. This goes to the switch. This goes to the one side of the motors, and this goes to another side of the motors. And over here there are three cables which goes to the three motors. The same on this side. Here we have a good look at Raspberry Pi 4. It's nice that they have enough space here to connect the USB. So this could be useful for some accessories like camera. There is some extra power port. I think this is in case if you will mount something here which needs power, you can take this power from here. And over there is a small RGB LED. I suppose this small RGB LED is going to shine through this plastic part. And the battery goes there. The robot was shipped to me without battery, so I used two 4-cell LiPo batteries connected in series to get required 33 volts. And here I switch on this robot for the very first time. Here in my office I have like 4 square meters of the floor where I can run this robot. So I just try to turn on the spot, go forth and back a little, sit and stand. The sitting process is quite aggressive and it feels more like a controlled falling. By the way, the robot can move also in this sitting position, but it cannot really turn properly in this position because of these 4 small wheels at the front and the back. At the same time, in sitting position, the robot consumes less power and motors have a chance to cool down a little. I also tried pitch and roll, and it works really well. I'm quite impressed. Now when I know that my battery works, it's time to put this robot into action. Fortunately, I found an empty office for the test. Let's try the high speed. I think the high speed is too high. At least for the indoors, it's too high. This is again standard speed. Look how it moves its legs during acceleration and deceleration. Like this, the main body stays horizontal. This is really cool and useful. You can also adjust the height in standing position, and this is the minimum height. And here you can see how it pitch and roll at different height, at minimum one and at maximum one. Maneuverability is really good. It can easily pass through the standard door frame. And even at low speed settings, it moves a little faster than the walking speed. And sit. I have connected the indicator to the battery to see the level of the charge. I'm really afraid to try this, but let's try to jump. Let's try one more time. When it jumps, the entire floor shakes a little, and so does my camera. Have you seen this? At high speed it leans when it turns, like a bike. I have made some customization to my robot. First of all, I changed the wheels here. I put the wheels with a bigger diameter like this. I hope that it's going to sit better without any violent boom. And also I put kind of gripper in the front. Let's see how it works. Now let's switch it on. Let's switch on the remote. Oh, from the first time. Just perfect. The second time. 2 out of 2. I know. Oh. Even like this, look. And let's try to sit. Okay, it's still violent, but I think it's a little bit less violent. Also, I did some tests outside, even though this robot is more suitable for the indoors. And one reason for this robot is not waterproof. And here I have a little bit of rough terrain, so we're going to test here too. A little rough terrain works fine. However, here it's also slippery, and this makes the balancing almost impossible. By the way, if the robot detects that it's going to fall, it stops all the motor for the safety reason. This is a good feature. I also wanted to include the slow-mo of the jumping. So here for the reference, the jumping in the normal mode. And here's the slow-mo front view. And here's the slow-mo side view. And now the most important part, conclusions. I found some advantages and disadvantages of this robot. Let's start with the advantages. First of all, this robot is super agile. It's more agile that I can control it with the joystick. And also it can jump. Second, it has a lot of degrees of freedom. So it has 6 motors, 6 degrees of freedom. And that's why it can do some crazy stuff like pitch and roll. Third point, the robot is customizable. You can design something to this robot, like I designed Gripper, connect it to the Raspberry Pi and control it through the SDK. You can also connect your cameras, robot arm or whatever you want. like LiDAR for example. The robot itself is well built, it's quite solid, and it has quite decent cable management. And the fifth point, which for me is the most impressive here, is the control algorithm. It's really well built, meaning that robot do a lot of interesting stuff, like for example when it turns, it leans. And also when it accelerates, it moves the leg in order to keep the body leveled. And these features are both impressive and useful. Now let's talk about disadvantages. First and main disadvantage that the source code of this robot is closed. But I can understand this company because I think this code is quite complicated. I think they spent a lot of time to develop this code and to tune it. And probably they don't want their competitors to use this code just like this for free. But still it's pity that it closed. I would love to steal it. The SDK for this robot is quite complicated and it's too complicated for me. I was not able to use it properly. I know that Direct Drive Tech, they're trying to improve this SDK and they're adding to the C++ the Python SDK. And I think the Python SDK is going to be way easier to use. The third disadvantage. This robot is too fast even at the low speed settings. At least it's too fast for me. But theoretically this can be easily adjusted in the software. The fourth disadvantage, I don't really like how this robot sits. It's like boom. It's more like controlled falling and not just sitting. But again, I think this can be adjusted in the software. But now it's closed, so I cannot adjust it myself. It's Direct Drive Tech who should do this. The fifth disadvantage is that at high speed setting, this robot is so fast that it can fall. Not always falls, but you can make it fall just with the joystick on a flat surface. Meaning that at some conditions, for example, if you drive force and back like this, and it swings like pendulum, at some point it can go faster than it can handle, and like this it falls. It does not fall really uncontrolled, it stops all the motors and it does not roll like this, it just falls on its wheels. But still I think this high-speed control mode could be reduced in the speed a little, at least in my taste. But this is probably personal. Maybe someone else wanted to have like high speed, the highest possible speed. And for me it's better to have lower speed but more controllable. Also I would like to point out a very important point. This robot is really powerful, it's quite heavy, so it can be dangerous. And this means that you should be careful with it. It's a real robot, it's not a toy, and it can easily break the bones. Thank you for watching this video till the end. Huge thank you to people who support me via Patreon and via YouTube channel membership. Here are their names. Thank you guys and girls, you are the best. As usual, stay safe, good luck with your projects, and see you next time.